Alright, we'll go to math.com. I'm going to click the calculus, go to continuity, and let's click on number 4 there. Okay, we got an absolute value, it looks like, involved in this one. Find the limit if it exists. We got the limit as x approaches 5 coming in from the left hand side of the absolute value of x minus 5 over x minus 5. So let's go over to the board. Let's write this one out. We have the limit as x approaches 5 coming in from the left of the absolute value of x minus 5 over x minus 5. Now, we want to look at this limit. That's what we've been doing in the previous problems. And of course, if we do direct substitution, we plug 5 in, we get 0 over 0. Now, there's really nothing we can do here, okay? And if we have an absolute value involved, that means that there's a piecewise function actually involved in this thing. So there's nothing we can do. Now, what I'm going to do here is actually sketch up what this graph looks like. That'll kind of help you see what we're dealing with here. So we're approaching 5, and let's just put 5. We'll say 5 is right here. Okay. Now, what I'm going to do here is let's look at the limit. Let's look at this guy right here, actually, and we're going to look at this numerically. Okay, we're going to look at this this numerically is what we're going to do over x minus 5. So by looking, looks like a 7 in there, didn't it? By looking at this numerically, let's take 4, for example, and let's plug 4 into this thing and see what we get. Now, really what we're saying is we're saying that f of x is equal to x minus 5 over x minus 5. And when we plug 4 into this, f of 4, we end up with 4 minus 5 over 4 minus 5, that's the absolute value. And so this becomes the absolute value of negative 1 over negative 1. But the absolute value of a negative is positive, so we have positive over negative 1. So this ends up as negative 1 right here. So when we plug 4 in, we get negative 1 out. And obviously this is not to scale, the graph is not to scale. So we're going to say that this right here is negative 1, this point right here. Now, right, okay. And if we plug in any numbers, let's say between 4 and 5, okay, we're going to get it negative 1. No matter what we plug in here, you're going to end up getting negative 1. Um, except you can't plug 5 in because we end up getting 0 over 0. So you see there's a hole here in the graph. We're going to say there's a hole there, missing point. But all these other numbers are going to end up being negative 1. No matter what you plug in, 4.3, 4.2, it doesn't matter. It's all going to be negative 1. So no matter what you plug in going in this direction, well, let's see. If we plugged in, for example, let's say we plugged in a negative 1 into here. F of negative 1, you get negative 1 minus 5 over negative 1 minus 5. So this becomes what? Negative 6. Right, absolute value of negative 6 over negative 6. but an absolute value of a negative is a positive, so we end up getting 6 over negative 6, and then this just becomes negative 1. Okay, so everything to the left of 5 is going to be, no matter what we plug into the function, is going to end up being negative 1. So what we end up getting here is a nice continuous line going in this direction, and all of its y values are negative 1. Now if we plugged in a number, for example 6, we'll say we're plugging in 6 into the function. We're running out of room here. F of 6. So we get the absolute value of 6 minus 5 over 6 minus 5, and we end up getting absolute value of 1 over 1, which is 1. Right? So we'll say 1 is here. Okay. Now of course if you plugged in 5 into this, like we said earlier, it's undefined. You get 0 over 0. So we're going to put an open hole here, and anything greater than 5 is going to be 1. Alright, so no matter which number you pick over here, you plug it in, you're going to get 1 out. So this is what our graph looks like right here. Okay, and this means that we have a left-handed sided limit, we have a right-handed sided limit, and they're actually two different numbers. Okay, so let's look at this. Remember, we were coming in from the left-hand side, so that means we're coming in from this direction here. Okay, and what is my y value approaching? Well, it's staying constant at negative 1. So there you go, negative 1 right there. Now if we were coming in from the right hand side and this was a plus sign instead, right, we'd end up getting what? We'd end up getting positive 1. It'd be a positive 1. Okay, so something else here, this function, this f of x here, is not continuous at 5 because the limit does not exist at 5. When I say the limit doesn't exist, this is what I mean. Coming in from the left and coming in from the right hand side does not exist, so that fails. But I mean, remember f of c, well f of 5 doesn't exist either, so that's actually the first thing that fails. So we know it's not continuous at 5, so I need to kind of throw that in since this is about continuity. Okay, oh my gosh, I hope you got all that. Alright, and we always go back to the page and make sure this number's correct, and it is. Okay, so check that out. Hopefully you caught all that. See you there. Bye.